Can you all see my screen? Excellent. Okay, yeah, I mean, so as I just mentioned, I'm a conservation scientist and a PhD student in Lindick's agroecology group at the Department of Zoology. So my interest in food systems really comes from an appreciation that agriculture is the biggest driver of biodiversity loss. So I'll first give you some sort of background on the biodiversity agriculture nexus, and then I'll talk a bit about my PhD research in India. So I really think that conservation can really not be successfully delivered if we don't consider how humanity meets its needs. So the graph here ultimately is the result of a modeling exercise and shows the current state of biodiversity and its response to future scenarios. So if you continue what we're currently doing, biodiversity will decline, shown in orange. And increasing conventional conservation approaches, such as protected areas and ecological restoration, would be needed to halt biodiversity loss, but by itself it won't be sufficient, shown in orange. You know, we're still below what we want to be, essentially. So we really need to address sort of the root causes of biodiversity loss, such as our broken food system. And the good news is that if we combine these traditional conservation approaches, but of sort of unprecedented ambition and coordination, with proactive policies targeting how, where, and what food is produced, we could, in theory, reverse global biodiversity trends caused by habitat conversion, while still feeding humanity. So, irrespective of sort of how optimistic you're about these sort of outcomes and scenarios, it is quite obvious that we need to address both food demand and supply. And so what you can see here is the change in suitable habitat for a range of terrestrial vertebrate species in response to agricultural expansion in 2050. So you can see here we have, you know, a range of different policies targeting, you know, both food demand and supply. And if you combine that together, that's really when we have the least, I guess, negative impact on the suitable habitat for species going into the future. And on the demand side of things, we have things like halving food waste and shifting to a healthier, predominantly plant-based diet. But so for any given level of food demand, we really need to also think about how we can optimize production to meet that target, but at the least cost to nature conservation. So for the remainder of the talk, I'll be talking about this supply side question. And so, for example, you can see here that closing yield gaps would be really important if we want to limit agricultural expansion and the associated habitat loss in the future. And answering this supply side question, I think really largely boils down to assessing how crop yield of a given place relates to its value for wildlife and associated functions and services. And unfortunately, there's frequently a negative relationship between yield and its on-farm biodiversity value. So basically, that means that if you want to increase the conservation value of an area that is used for agricultural production, that usually lowers its yield. So that in order to meet a given level of food demand, you need to increase the area that is under production, which then means they have less room for area that can be only or primarily dedicated to nature conservation. So that's land sharing and shown on the far left. And in contrast, you have land sparing, sort of the far right, and that involves sort of assigning more space with the primary focus being nature conservation, so natural forests or savanna, whatever it might be. But then obviously to meet that same food production target, you do have to increase the crop yield on existing farmland to meet that same food production target. Yeah. And empirical evidence so far suggests that for most species, land sparing usually outperforms land sparing, mainly because there's so many species that can't cope with any form of agricultural production and are restricted to this natural ecosystems. But one thing to stress is that obviously high yield has to be achieved sustainably. And so a farming practice or strategy that ultimately erodes or limits the capacity of a given piece of land to produce food over the long term obviously can't be part of a successful sparing strategy. So really we want to be in this safe space for food production. Obviously we need to produce enough food, but we want to limit the negative environmental impacts. And I was saying earlier that yes, there is frequently or typically a negative relationship between, or trade-off between yield and the on-farm biodiversity value. But sort of win-win solutions, so actions and management options that enhance wildlife in the agricultural landscape itself, but do so without reducing yield or potentially even increasing yield, are obviously encouraged and what we should aim for in a way. And examples or strategies of this may be collectively referred to as ecological intensification. And ecological intensification involves sort of amplifying ecosystem services to increase food production per unit area. And in sort of contrast to conventional intensification, it involves being in this safe space essentially for food production. And there is a focus essentially on providing habitat or resources for the animals or organisms that promote plant growth. So it's about, for example, increasing soil health to support microorganisms that promote the plant growth, or providing habitat for pollinators, for example. And so the actual techniques you use, can be shared with other forms of, sustainable agriculture, such as regenerative agriculture. But with ecological intensification, there's a real focus on improving yield or having high yield. And I think that's quite important from the biodiversity perspective. And my PhD ultimately looks at one of these ecological intensification strategies in India. But let's first take a step back, why India in a way, and so what are the particular challenges with food production, with reconciling food production and biodiversity conservation there. And as you can see here, that the environmental pressure imposed by food production is particularly high in India, really, well, one of the highest or the highest in the world. So, I mean, that obviously comes down to a lot of land in India is already under agricultural production. And that means obviously that sort of implementing any area-based conservation efforts will be particularly challenging in India. And their conservationists are advocating for vastly increasing the protected area network in the world. And for example, the Half Earth movement involves dedicating really half of the someone's joined half of the world's surface to nature conservation. And if we did that on the global level, we already see that there are, that there will be crop calorie losses in India. But if we did that on the sort of Hello, can you hear me? I think my screen is frozen.
Right, we can still hear you.
Ah, can you hear me now?
Yes, yes.
Oh, okay. You all stopped for me and my screen froze, so good then. Oh, no. Okay, wait, let me just stop sharing. I'll start sharing again. Is that working now? Sorry, is that working for you?
Yes, yes.
Okay, cool.
Yes.
Sorry, I think my just computer decided it was too much and gave up. Yeah, so but if we did that on the sort of country level, so if we actually dedicated half of India's land surface to nature conservation, we obviously have real conflict with feeding enough people. So I think it basically really matters. Yes, we do need to increase yield on existing agricultural land to be able to implement any sort of area-based conservation efforts and sort of be able to conserve species that are clearly incompatible with agriculture. But how we increase yield obviously really matters. So here we've got an overlay of the intensification potential. So how much more can we intensive agriculture and increased yield, and overlaid with endemic richness, so of species that do use cropland on a regular basis, but they also are found nowhere else on Earth, basically. And we can see here, obviously in India, there's quite a bit red areas, so a high intensification potential, but also, you know, a high level of endemism.
I think that's rubbish.
Say again?
Sorry, no, I don't. I think it was
Oh, sorry, just someone.
Go ahead, sorry.
No worries. Cool. So a farming practice that has received a lot of support from sort of communities and the government alike in India is called zero budget natural farming, ZBNF. And the zero budget part refers to sort of the aim of drastically reducing the need for financial inputs, and sort of ending the farmers' reliance on, you know, synthetic inputs bought from big corporations, and because they're often very indebted, and partly because of that, the suicide rate of farmers is very high. And the natural farming part refers to the agroecological basis upon which these expenditure cuts are to be achieved. So there's a big focus that essentially is about sort of using locally made ingredients, you know, things like, well, cow dung and neem oil to sort of produce these treatments. And yeah, it is not completely zero budget, but the expenditure cut should be a lot lower. And there's a big focus on improving soil health ultimately. And it could be seen basically as an example of ecological intensification, because evidence from sort of farmer self-reports and this plot soil experiment shown here show that the yield can be higher in comparison to conventional farming. But I should say that the evidence base is really very, very limited, and you know, there's a lot of more work needs to be done to really understand the effect of ZBNF on ecosystem functioning, you know, soil health, biodiversity, and all sorts of things. But in a way, despite this very limited evidence base, it has received an incredible amount of political support. So, for example, Andhra Pradesh, the state I'm working in, they want to convert all farmers, so that's 6 million farmers in the state. They want to convert all of them to ZBNF by 2030. And there has been interest by other states and actually internationally as well. They were at COP26, for example. And there are quite a fair amount of government officials in India consider ZBNF to be the future of sustainable farming in India. And at the moment is really one of the biggest experiments in agroecology in the world right now. So I'm interested in assessing the farming system-wide biodiversity effects of ZBNF and sort of how it compares to other agricultural strategies. And in order to compare the merits for conservation of different agricultural strategies, we need information how the population density of each species of interest responds to land conversion to begin with, but then also yield increases. So we need to have density data for agricultural sites that sort of span in a way that spectrum of agricultural productivity that can be found in the landscape, as well as in natural ecosystems. And so previous studies have plotted this, you know, you've plotted the density against your crop yield, and then looked, you know, which are the winners, you know, which species actually do better in agriculture compared to natural ecosystems. But obviously most species are losers, so, you know, the density declines. But according to the shape of how they're declining, it might be either then sparing or then sharing that might be a better agricultural strategy for a given species. But this obviously doesn't tell you anything about how a given yield is achieved. And for me, this really matters because, for example, with ZBNF and chemical farming, the yield might be the same, but the actions of on-farm biodiversity value might be very different. So in order to sort of investigate this, I spent quite a few months this year in the northeastern part of Andhra Pradesh, shown here. So my study site essentially is 500 meter by 500 meter squares, and I'm basically doing bird surveys in those to estimate the density of different species. So I've got 13 chemical farming sites, 13 ZBNF sites, and then 25 forest sites. And the chemical and ZBNF sites span essentially this gradient of the amount of sort of natural habitat patches here described as complex habitat found within the square. And in order to sort of examine the effect of land use and land management, I need to sort of account for obviously the biophysical variables that might influence my outcome of interest, that being bird density and crop yield, but obviously also the likelihood of a site being converted to agriculture to begin with and a particular farming practice adopted. So, for example, the natural habitat patches I was showing earlier, they're obviously likely to influence the bird density we can find in a given site. They're likely to influence yield, obviously, because you're taking land out of production, that if you're measuring on square level, that will reduce your yield. But you're also providing habitat for some service providing animals, so pollinators, for example, so that on the bit that's farmed, they might actually increase your yield. And that it can also obviously affect the likelihood of said BNF or chemical farming. So, in areas and agricultural landscapes where you have a lot of natural habitat patches of trees, farmers might be potentially more likely to adopt said BNF in comparison to chemical farming. And I know the audience is quite diverse today, so in a way, people from other disciplines might be in a way astonished to hear that sort of counterfactual thinking and associated methods such as statistical matching, sort of this impact evaluation, is actually very new in conservation science. So if there are any sort of impact evaluation experts among you, please do get in touch. But so essentially before I went in the field, I spent a lot of time trying to make sure that my sites are matched in terms of elevation, slope, soil type, precipitation, but also the habitat patches and for the farmland sites. Because, for example, going back to last point, you can see I tried to make sure that they're very similar, but obviously there are still some differences in terms of the complex habitat patches. So we can account for that later on statistically by sort of essentially giving the sites that are where the covariates are more similar to the other farming practice, we can give that basically more statistical weight, and the ones that are quite different, we'll give less statistical weight essentially. So after doing that, said BNF and chemical farming are quite well matched, which should allow me for quite good causal inference, basically. But if we do this for forest, said BNF and chemical farming, we have the common issue that most of the sort of active land is already taken by agriculture, and what's left for biodiversity and natural ecosystems are sites, with the lowest opportunity cost, so far away from human centers, high up in altitude, steeper slopes, things like that. So basically, even after doing the statistical weighting, there's still differences between my forest sites and my farming sites. So here I'm dealing with it by basically including the statistical weights, but also then including slope, elevation, and soil type as covariates later on. So basically, I've just completed one field campaign so far. So I can't really share with you lots of really exciting results. So I have to give another talk in a year or so. But sort of very basic processing of the data, quite unsurprisingly, shows that I record a lot more species in forests. So the graph on the left is basically a species accumulation curve. So with increasing efforts or increasing number of visits, obviously the number of species I detected increases. It shouldn't be seen as something to compare different habitat types. So it's more about assessing how effectively I surveyed a given habitat type. So obviously, it's basically as the curve flattens off, I don't record many more new species with a given visit. So I've quite exhaustively sampled that given habitat or land use type. And basically what you can see here is that there's quite a lot of overlap in terms of the actual species identities. The species shared between said BNF and chemical farming are quite high. So there's a lot of species overlap. But if we talk about, basically there are a lot of species, or over half the species I record in the forest are only found in the forest and on the chemical farming sites. So unsurprisingly, we have a lot of forest specialists that can't cope with any form of agriculture essentially. But actually these sort of species richness indicators, they're basically very uninformative biodiversity indicators. So we really want information on density, and that's what I'm currently doing. So I'm trying to estimate the density of the 150 species that are recorded at each site. I'm trying to explore questions such as, are there differences between the 3 different land uses, and how does the amount of natural habitat patches in the landscape predict the abundance of a given species, and whether it could be an interaction, whether it depends on the habitat as well. But most of the questions I'm interested in require yield data. I think I've probably labored this point enough, but bird density data alone is not sufficient. I mean, we already know quite well that obviously agriculture, you find way fewer species in agricultural size compared to forest. The community is quite different, and some farming practices, such as agroforestry, are home to a lot more species. But I think without yield data, we can't really assess the sort of farming system-wide biodiversity implications. And especially, for example, ZBNF, any biodiversity impacts could be, okay, there could be a higher on-farm biodiversity, but they might not differ. So any positive biodiversity impacts might come about through increased yield and then being able to set more land aside for forest potentially. So this is why basically I'm going back to India in a couple of weeks. So I'll be interviewing farmers this time and also getting information on economic profit. So I'm collecting cost and revenue data because whilst yield could potentially be quite similar between ZBNF and chemical farming, I expect the economic profit to be potentially quite different between the two. I mean, the whole aim of ZBNF is really to reduce the cost to farmers and increase profit that way. So I think the shape between sort of density, depending on whether you have yield on the x-axis or economic profit could, I think, really change the shape of these curves. But yeah, so once I have this field data, I will then sort of start to explore different scenarios and ultimately try to identify the agricultural strategy that maximizes the abundance of a given species. And yeah, for that, I first need to get and construct these density yield curves separately for ZBNF and chemical farming, and then also gain an understanding of how the density of a given species relates to the amount of natural habitat spreaders at various scales. And with that, I can then basically explore different scenarios. So I can set a food production target, that can reflect current demand or going into the future, expecting demand might increase. And then I can ask the model to run thousands of different options, essentially, of how, pick different pixels where each pixel might be, or planning unit might be forest, or it might be, or it's basically a unique combination of farmland with a given amount of habitat patches. So it could be ZBNF with, let's say, 10% natural habitat patches, and then it will, the model basically figures out all the different ways of how this food production can be achieved, and then it will tell me, okay, basically with which scenario basically gives me the best biodiversity outcomes, so the highest density or abundance of a given species. So ultimately, it gives me the optimal or near optimal solution for bird conservation. But I can also use this sort of scenario planning to essentially test for specific hypotheses, and also explore what would happen to bird populations, for example, if really all of the farmers in the state converted to ZBNF, and also what would the food production outcomes be. So if I don't limit the food production, I can also explore the effect of that. Great. So to conclude, changing what, where, and how food is produced is really critical if we want to halt biodiversity loss. Stopping agriculture expansion will be particularly important and requires increasing yield sustainably on existing farmland. And in order to assess farming system-wide biodiversity implications, we need data on crop yield, on the species abundances in agricultural sites, as well as in the natural ecosystems. Great. Well, with that, thanks a lot, and happy to take any questions.
Thank you so much, Iris. It's certainly fascinating. I'm glad that you were able to go to India and spend some time there. I'm sure at some point it must have been quite difficult to see a lot of people clapping at your presentation. I have a very quick question before we open up. I wanted to ask you, are you also looking at, in the ZBNF, are you looking also at the impact on disease management and also soil erosion management? Is there a difference, and how is it going to change? I'm not quantifying directly. I'll probably collect some sort of basic data, and obviously I need to understand exactly what the impacts are, because it's sort of easy to begin with a class into ZBNF and chemical farming, but on the ground there's so much variation of what farmers are actually doing. So I do want to capture that. I'm not directly measuring like sort of pest control or anything like that. I am looking at pollination, so I didn't have time to discuss this now, but I'm also doing
pollination experiment when comparing cashew pollination service provisioning between ZBNF and chemical farming, and sort of looking at the number of different pollinators visiting the flowers, essentially.
Okay. I wonder, do you know if there's anyone else who's doing a similar project but looking at kind of parallel aspects that could give you a 360-degree vision of the project?
Not to my knowledge. People are looking at more, well, there are a few other PhD students, some are looking at sort of more the political ecology side of things and women empowerment and rights, so like more the social side aspect of it. And there's someone else is looking at soil, so because people are saying ZBNF could be % of natural climate solution, you know, like sort of having low greenhouse gas emissions for rice. So there's someone looking at that, but apart from me, I don't think anyone's looking at biodiversity.
Okay. Okay, I have a few other questions, but I want to open up the floor. Please, anyone with questions or comments for Iris? Martin.
We had in this last time, we had another PhD student who was looking. His main concern was actually with gas emissions, but he was highlighting the significance of a balance between wet farming and dry farming, which had some fancy interaction with gas emissions. But it also struck me, I don't know how much wet rice there is in your area, but I just wondered whether you were looking at the balance between wet farming and dry farming and how that interacted with biodiversity and whether there were balances which were more or less optimal. Yeah, I mean, I know that basically that's not really a focus of ZBNF, like altering in that way. I basically, within these 500 by 500 meters squares, I just basically looked at any crops that were within that, and it tended to be a lot of rice, right? But mainly wet farming. And I'm not really directly looking at the differences in that, and I'm not sure there would be necessarily with ZBNF and chemical farming. Very interesting to explore as well.
And Iris, are you looking at also the different crops that are going to be cultivated? Is there a shift towards, you know, maybe let's say the neglected or orphan crops, or rather than, you know, the usual ones?
There is on paper a lot. In practice, I haven't found that much of a difference. I mean, yes, there will be now that I'm interviewing farmers. I'll get obviously information, you know, what crops are they growing and the season and things like that. But sort of what I had a feeling on the ground last time, I don't think there's that much of a difference. Yeah, I think it's promoted and desired, but I think not so sure that that's not necessarily happening on the ground.
Okay, thank you. I'll follow up on this for in a moment,
yeah.
But I want to let
I mean, I think there's something interesting, like diversifying, like growing loads of more different crops. But yeah, so I definitely found quite a disagreement of what's happening on the ground versus what they'd like to see.
Yeah, because there might be quite a big impact if they shifted to different crops. David, you have a question or a comment, please?
Yeah, thanks very much for the talk. So yeah, you're saying that the evidence is currently really sparse. Like instinctively, how optimistic are you for the prospects of this technique? Do you feel like it does have quite a lot of potential? And then coupled to that, how unique are the benefits to India or this part of India? Do you think this is essentially something that can easily be transferred in terms of how they approach it? I was Googling about how they use a specific combination of manure and things, and I don't know whether that's only applicable to India or whether you can easily adapt it to other places.
Yeah, I mean, I think it's definitely quite messy on the ground. I mean, I'm also not a soil scientist, so I might get things wrong, but I mean, so previous studies that looked at more trying to kind of yield, it definitely depend on the crop and sort of, because Andhra is quite big as well, so it depends on sort of the bioclimatic region. So I think for a drier region, they actually found more of an effect. So there seems to be a lot about moisture holding capacity, like any positive effect. But in terms of, I don't know, I think it depends obviously what your baseline is and like what you were doing before. So I think, you know, these areas dominated by smallholders and you know, even sometimes some villages I was in, you know, they're very poor tribal farmers, and they weren't even practicing chemical farm. They were just basically doing nothing. I mean, there was always no management. It wasn't even organic or anything. So then just doing ZBNF, yes, will probably have some positive impacts. But whether that's, I doubt that's suitable for, you know, a farm that has like, you know, high input technology and has a lot of big fields. So I'm a bit like, I think it's obviously not as like perfect as we're trying to now, but I think there could be benefits. And in terms of, I mean, I think it is one of those practices that you can't, yes, it could be applicable to other areas, but I think it's, I mean, it's very knowledge intensive. And I think, you know, in general, that sort of blanket approach, oh, this worked here, let's just do it somewhere else. I don't think that's, I mean, I think that's the same for any farming practice, you know, like sort of having locally adapted, suitable approaches would be, but yeah, I think it's like sort of possible, but you would have to definitely trial it quite a lot.
Thank you, David. A couple of people were super interested and had to leave. I see people have to leave, but I'll put you in touch with all those people who've left a comment, and I know them, so I know that there will be good connections there. Anyone else would like to ask a question or make any comments?
Just out of interest, is anybody else looking at any other elements of the ecosystem within your 500 meter, or is it just you alone? Is anyone looking at the insects or anything? Or
no, I mean, yeah, I'm doing insects as well, but that's in a different plot. That's just the cashew. So sometimes they're like the same village, but not exactly the same, you know, plot sort of thing. But yeah, a lot of work to be done.
That's why I was asking you, Iris, if there are other people looking at other aspects, because I can see that there are so many elements, right? You know, you can look at rainwater retention, soil degradation, of course, and also the shift towards more suitable, in a way, more suitable crops. Looking back at ancient crops, which might be better suited to this, ZBNF. So I guess maybe you can suggest it to Lynn to expand it.
Yeah, exactly. Yeah, I think that's a general an issue with India, though. Like, you know, like culturally, some crops are so important and just grown in areas where they just really not suitable. You know, like, and I think I really noticed that during the first week of being like the drastic impact of climate change. I don't know, for example, cashew, they had unseasonably late rains in the season before, and that meant that this black fungus really spread. And I mean, the farmers were reporting like 1/10 of the yield they're normally getting. So it's just really completely shifting seasons, and then other parts are just, you know, obviously more northern India, just extremely dry and hot, and you see the maize, you know, drying up. So I think, yeah, I could really feel the impact of that.
I just add on that one. No, just in terms of, I should explain, Iris, I'm an archaeologist, but those cultural importance things, they're absolutely rigid until they change, and then they change in one generation. So there's lots of examples of really big shifts in crop, and the previous generation said, you know, never in a million years would I ever do anything different from this, because we've done it forever. And then the circumstances are right, those cultural shifts can just happen overnight. I mean, I'm not saying it's easy, it's just that empirically there's lots of examples of that.
Yeah, please come to India and talk to the policymakers. Right?
Martin, is there a consistent trigger of that? Is it always like economic incentives, or does it vary?
I think the consistent thing is that there has to be a fragility in the existing system, but I think here there is. Do you know what I mean? There has to be a fragility, a vulnerability in the existing setup, and at that point,
then it's like a dam breaking.
What the fragility is can vary from context to context, but once that happens, the change can be dramatic.
Yeah, I think when people start to see, people start to see their neighbors or something like that, right? Like there's a certain viral effect as well when you see somebody succeeding in some way.
Yeah, and also the social constraints on conservatism weaken. That's a very important point. I mean, a lot of the farmers that are still, it's not that they lack imagination, it's just that there's enormous social constraints and expectations, and the weakening of those can reveal the kind of innovative exploratory thing that was there all along, but it was very much hemmed in by social constraints.
Yeah, I think that, I mean, I think the farmers are very understanding of the changes going on, very willing. I mean, they're desperate to like change practices, you know, as needed. But I think the issue is more like, you know, people in India eat a lot of rice, and I think changing that, you know, as a will be potentially quite difficult in terms of.
But that's again, that those changes happen. You know what I mean? And those changes historically happen. Of the staple, there is often this incredible attachment to the staple. And then it changes, and a new staple comes along, and then very quickly there's an incredible attachment to that, which is also bound up sometimes with the same cultural narratives. You know, especially if it's something. I mean, with whole grain, it's different, but especially something that's made into flour, which I realize is different from the rice. Then you can just switch, and the same cultural narrative is brought in to be equally conservative and yeah.
Yeah, that's true. So Iris, when are you going back? In 2 weeks, you said?
Yeah, on the 4th of December. So quite soon.
Okay. Well, are you spending Christmas there?
Yeah. I'll be going for the 6 months or so.
Oh wow. Okay. Well, keep us in keep in touch and let us know how things progress. If there's anything also that we can contribute from here, of course, and that'd be great. So anyone else would like to add any more questions or comments? Iris, would you like to add anything that you didn't cover?
I don't think so, not on top of my head. I mean, if someone works in sort of India or any sort of similar issues, you know, so please do get in touch. I'd love to hear about your work as well. But yeah.
Yes, definitely. Great. I guess several people have to leave now as well, but it's been really interesting. And Iris, I will put you in touch with several people who might be very helpful to your work, and of course the people who are at the seminar today. Thank you so much. Thank you so much, and thank you everyone again. And yeah, have a good weekend.
Thank you. Bye.
Thank you. Bye bye.